Good morning, this is Mr. Duncan at the Bonham Public Library, and I'm going to show you kind of a fun experiment involving vinegar and baking soda. Now you're thinking, oh my gosh, a volcano, right? Is that no? I'm going to really talk about the chemistry of this and demonstrate something that you can do at home with a bit of supervision, but it's a lot of fun to try. What I'm basically going to do is I'm going to pour some vinegar into this bottle. Let's put this in and set it aside. And I'm going to add some baking soda to it in a minute. Now, if you're thinking it's going to be spouting out the top, just no. I'm going to be doing something slightly different. So I put a bit of vinegar in here. It doesn't take much to do this. As far as what's spouting out of here, well, you've seen the foam and the fuzz. Basically what vinegar is acetic acid. That's the main ingredient there. And the baking soda is sodium bicarbonate. So an acid and a base. And when you put an acid and base together, you get a chemical reaction. In this case, the chemical reaction releases carbon dioxide, water, makes water molecules, and a new molecule called sodium acetate. Okay, so much for the chemistry. What I'm going to do to get the baking soda in there and hold the gas, which happens to be carbon dioxide, is I'm going to use a balloon. You're going, well, how do you do that? I'm going to put the baking soda in the balloon. So what I'm doing is, I've got a piece of paper, I'm going to curl it up to make a funnel. Move that out of the way so I don't knock it over. So I'm going to make a paper funnel like this so I can get the baking soda in there. What I did is I put some baking soda in a cup like this. So I'm going to throw that in there. This is about a tablespoon of baking soda going in here. And I measured that out. If you notice I had a little bit of spill down there, I would do this in a place that is fairly open, clean. In a little bit, we're going to be using a candle and flame, so you have to take that into account. We're going to talk about the properties of carbon dioxide gas. So what I'm doing is I am getting the baking soda to slide in there nice and neat, no mess. All right, hold on. For the most part. Okay, we got that in there. Put that aside, get this on the bottle, and we're going to put the balloon on the bottle. Now try not to tip it in quite yet. You want to put it over so that balloon is right over the top, and you want to hold this. You ready? So get the baking soda in here. I'm going to let it go. And as you can see, it's foaming. And we have filled the balloon with gas. Now, if I were to let this out into a container, this gas would fill the container. It is denser than the air around it. We breathe about 78% nitrogen, 21% oxygen, and some other gases, including carbon dioxide. But in its concentrated form, carbon dioxide is denser than the air around it, which means it will sink to the lowest spot, which brings us to the next demo. So I got my gas right in here, but if I were to try and use this on a candle here, you wouldn't be able to tell the difference. It'd be like going blow it out. So I'm just going to let this out. Okay, we'll put that aside. Instead, I'm going to bring some more baking soda, a lot more, and I'm going to get a measuring cup. And I'm going to put some vinegar into the measuring cup. Not too much. Like I said, it doesn't take much to do this. Now I'm going to set these aside for a second, because then I'm going to bring in the star of our show, which happens to be an old birthday candle. Yes, it was my, let's see, I just had my 3rd birthday, right? And a lighter. Now, here's the point when I talk about safety. If you do this, I'm going to strongly suggest that you have a parent supervising you. If you're old enough, you could try this out, but you need to do this in a place where, number one, I've got a paper towel under here, I've got paper, I gotta make sure I don't set anything on fire or burn myself. This is a safety lighter, so I'm gonna light this, and this is one I borrowed from the library, so it really, what's set like that, that's not great. It should just be a nice little flame. But like I said, it was whatever I could scrounge up. So what I'm going to do now is I'm going to leave the candle lit, and yeah, I could go like that, blow the candle out. You didn't see that. Okay, let's try that again. It's been one of those mornings. Got it. Okay, let's go back here. I blew the candle out, and as you can see, I'm just using this kind of candle here. You want to use a small candle for this. And I'm going to make some carbon dioxide gas. Fizz, fizz, fizz. You can't see the carbon dioxide gas. It's colorless, tasteless. I'm going to let the fizz come down for a minute. But I'm assuming that it is denser than the air, so right now, this container looks like it has the same air in it, but the air has been displaced. The carbon dioxide has been made, it's gone up to the edge, and it's displaced the air outside. So there's a layer of gas in there, and this carbon dioxide. And if I do this right, I should be able to pour it out. Did you see that? I just poured out the candle. You're going, what? What do you mean? You blew out the candle, didn't you? Well, still carbon dioxide gas in here. It was flowing like water out of here, and it flew over here, and it deprived the flame of oxygen. And you're going, no, 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 that's just messed up, right? Well, here's our container. Here's our candle. If that's true, if this is full of carbon dioxide gas, it should not support a flame because you need oxygen to support combustion, which is what this is. So if I take this and try and put it into the container, watch what happens. Did you see that? I'm not putting in the liquid. I can't even light it in there. Oh, it's broken? You're saying it's broken? Oh. There's something in there that is not the atmospheric air. We got 21% oxygen out here, which is plenty to support the flame. There's no oxygen here. And you can think about all of the safety things that happen with this, with carbon dioxide gas. You can think about all of the natural phenomena. There are areas in volcanic regions where carbon dioxide gas seeps from the magma below into low spots, and those are dangerous places for people to go because you can suffocate in these low spots. Now, if you want to Google it, you look at carbon dioxide and volcanism, you might run into this. It happens quite often in volcanic areas in Africa. It can also happen in mines. Okay, you can walk into an area and have carbon dioxide gas in that space, and it can very quickly make you become unconscious. Interesting stuff. So I suggest you do a little research on this, plus you can play around with this. If you want to make the volcano, that's great, okay, but take it a little step further and just remember your safety. And you have a good day and have fun, and I've got some more chemistry things coming up very soon. Later.